This video covers an important topic, the sine rule. The sine rule is a set of equations that relate the lengths of a triangle and the interior angles of a triangle. Take, for instance, this red triangle here. Imagine I label the red triangle as follows. So I'm going to call this angle A. I'm going to call this angle B. I'm going to call this angle C. So notice that I've labeled the angles with uppercase letters of the alphabet. Now I'm going to label the sides. Now I'm going to label the side opposite to angle A with this lowercase a. So I'm going to say this side here has a length of small a. The side of the triangle opposite to angle B, I'm going to label as having a length of lowercase b, so small b. And the side of the triangle opposite to angle C, I'm going to label as lowercase c. Now the sine rule allows one to do the following. You can pick a side, write down its length, divide that length by the sine of the angle opposite to that side. So the angle opposite to this side is angle A, and the sine of angle A is written as sine A. Now the sine rule allows me to write this fraction and equate it to the following. I can pick another side, so I'm going to pick this side, write down its length, and divide that length by the sine of the angle opposite to the side I just chose. So sine B. And I can do the same for the last side. I can pick this side, write down its length, and divide it by the sine of the angle opposite to the side I just chose, which is sine C. So essentially what the sine rule is saying is that the ratio of the length of a side to the sine of the angle opposite to that side is equal to the ratio of the length of any side to the sine of the angle opposite to that side. And that's what this equation is. And this equation is a sine rule. And remember from what I said earlier, the sine rule is actually a set of equations. Here's one equation. That's one equation, right? And here's another equation. Each equation involves one equals to symbol. Here's another one, and here's another one. You could say A over sine A is equal to C over sine C, because if A is equal to B, which is equal to C, that means A is equal to B, that means B is equal to C, and that also means A is equal to C. That's another equation. Anyway, let's move on. So let's take this green triangle, and I'm going to label it as follows. This side is going to have a length of 5 units. This side is going to have a length of 3 units. This side here is going to have a length of 4 units. I'm going to let this angle be a right angle, and then for these remaining 2 angles, I'm just going to leave them as unknown angles. And now I'm going to show you how the sine rule can be used to determine the values of the unknown angles. Sine rule says I can pick a side, write down its length, divide that length by the sine of the angle opposite to that side. The angle opposite to this side of length 5 is this right angle, which is an angle of 90 degrees. So I have 5 over sine 90 degrees. And I can say that is equal to 3 divided by the sine of alpha, which is equal to 4 divided by the sine of the angle opposite to the side of length 4, right? So in other words, one could say, let this 5 be this small a here, which means that this angle here is actually capital A. So that means A is 5 in this case, and capital A is 90 degrees. You could say B is 3, so this is B, and alpha is uppercase B. So you see where I'm going. So we're applying this sine rule to this triangle here, and this is what we have so far. So how do we determine the unknown angles? Let's pick an equation where there's only one unknown. In this equation, the only unknown is alpha. 5 is a number, 3 is a number. Sine of 90 degrees can be evaluated to give a number, but alpha is unknown. Well, the sine of alpha is unknown, let's put it that way. And we know that from the sine of alpha, you can determine alpha by taking the inverse sine. But let me just proceed. So from this expression, I can cross multiply to give 5 sine alpha is equal to 3 times the sine of 90 degrees which means that the sine of alpha is equal to 3 times the sine of 90 degrees divided by 5, which gives that the sine of alpha is equal to 0.6. Now if I take the inverse sine of both sides, I'm just going to do that down here below. The inverse sine of both sides in this equation we get alpha is equal to the inverse sine of 0.6. This is something you can determine using your calculator. There's a video that covers how to do so, and doing so gives an angle of 36.9 degrees. So alpha is 36.9 degrees. So we now know this angle. The only unknown angle now is this beta. One could use, well, like I said, you could use this equation. This is another equation. Let me use a different color, blue. This is another equation. 3 over sine alpha is equal to 4 over sine beta. We know what alpha is now, so you can say 3 over sine 36.9 is equal to 4 over sine beta. Again, here we have an equation. The terms are just ticked unknown, but sine beta is unknown. So you can cross multiply and make sine beta the subject of the formula and solve for sine beta, and then take the inverse sine to find beta, and you get an angle value. But instead of going through that long process in this case, one could just note the fact that the sum of angles in a triangle must always be equal to 180 degrees. That means alpha plus beta plus this right angle here must be equal to 90 degrees. So I'll write that here. Alpha plus beta plus 90 degrees must be equal to 180 degrees. So alpha, which is 36.9 degrees, plus beta plus 90 degrees must be equal to 180 degrees. That means that beta is equal to 180 degrees minus 90 degrees minus 36.9 degrees. And that gives that beta is equal to 53.1 degrees. So I've just demonstrated a typical application of the sine rule. The sine rule relates the lengths of sides of a triangle to the interior angles of that triangle. And sometimes you have cases where an angle is unknown or the length of a side is unknown. All you have to do is use any one of the suitable equations within the sine rule to determine whatever you're looking for. I say any one of the relevant equations because the sine rule is essentially made up of 3 equations. As I mentioned earlier, this is one equation. It's 1 equals sine. It's saying this is equal to that. So 1 equation. Here's another equation. We're saying this term here is equal to this term. And the final equation is where you say this is equal to this. Now imagine this gray triangle is labeled as follows. This side has an unknown length x. This side has a known length 10. This side has a known length 12. This angle is an angle of 56.2 degrees. This angle is 80 degrees. And this angle is an angle of 43.8 degrees. How would you work out the value of the length of the unknown side, which I've labeled as x? What is x? We're looking for x. Well, you can use the sine rule because you know that x divided by the sine of the angle opposite to x is equal to the length of any other side divided by the sine of the angle opposite to that side. Now here we have an equation and the only unknown is x. So if we solve this equation by making x the subject of the formula, x can be determined. So let's cross multiply to get rid of the fractions. Cross multiplying, so x times sine 56.2 degrees and then 12 times sine 80 degrees, and that gives x sine 56.2 degrees is equal to 12 times the sine of 80 degrees. Dividing both sides by sine 56.2 because this is essentially one term. This whole expression refers to some number which you can work out. I'm going to do that at the end. So anyway, dividing through by the sine of 56.2 degrees gives 12 times, well, sine of 80 degrees divided by the sine of 56.2 degrees. And simplifying gives x is equal to 14.2. So the length of this side is 14.2 in whatever units. And that's essentially, we've just shown two ways of applying the sine rule. And if you understand this, then you pretty much understand the sine rule. All you need is just more practice with examples. So here's just a summary of the sine rule. Say I have a triangle. Let this angle be uppercase A. Let this angle be uppercase B. Let this angle be uppercase C. Let the side opposite this angle with uppercase A have a length of lowercase a. So this is uppercase C. So the side opposite this angle have a length of lowercase c. And the side opposite this angle, uppercase B, will have a length of lowercase b. Now the sine rule is simply, the ratio is basically an equation that, it's basically a statement that equates the ratios of the length of sides to the sine of the angles opposite to those sides. So A is the length of this side, and the angle opposite to this side is uppercase A, and here we have sine of A. So A over sine A is equal to B over sine B is equal to C over sine C. Or you could say sine of angle A divided by A is equal to sine of angle B divided by B, which is equal to sine of C divided by C. So there are two forms of the sine rule, but they're essentially the same thing. This equation is just the reciprocal of this equation. Well, this equation is obtained by taking the reciprocal of each of the terms of this equation. But one thing I need you to note is that this equation here, equation 1, is actually 3 equations. And I'll show you. Now, here's one equation. Equation simply says that A divided by the sine of A, angle A, is equal to B divided by the sine of angle B. Here's another equation. This equation says that B divided by the sine of angle B is equal to C divided by the sine of angle C. And there's a third equation, and it's just simply that A over sine A is equal to C over sine C. A divided by sine A is equal to C over sine C. And why is that true? Well, if I have an equation like this, x is equal to y, which is equal to z, you can easily say that x is equal to y and y is equal to z, so x is equal to z. X is equal to y is one equation, y is equal to z is another equation, and of course x is also equal to z because x is equal to y. And since y is also equal to z, that means I can replace y with z, so x is also equal to z. That's the same thing as happening here. A over sine A is one term, which is equal to B over sine B. But because B over sine B is equal to this term, that means this and this must be the same. Basically, all these terms are equal to each other. So you can say, well, this is equal to this is one equation, this is equal to this is another equation, and this being equal to this term is also another equation. That's all here. You can do the same thing with this expression. You can say that this expression is essentially 3 equations because you have that, well, you have this one equation here, and you also have this as another equation, and you have the fact that this term is equal to this term. So these are 3 equations, and these are the 2 forms of the sine rule. It's one thing to know how to use the sine rule, but it's another thing to know when to use it. And it's actually, I think, even more important to know when to use it. What's the point of knowing how to do something if you don't know when to use it? I mean, if you know how to do it, then you can't actually use it. If you don't know when it applies, you don't know when it's useful. So what I'm asking is, when is the sine rule useful? So let's start from the fact that the sine rule is a set of equations that relate the lengths of a triangle to the angles of a triangle. So essentially what we have here is a triangle with 3 sides, length A, B, C, and 3 angles, angle A, B, and C. Of course, you take the sine of angles. And like I said, the sine rule is a set of 3 equations. Here's one of them. Now let's say this length A was an unknown value, but let's say B was known. So let's say you knew that B was 10 or something. Let's say this angle B was known. Let's say you knew B was 60 degrees or whatever, and you also knew angle A. What that means is that the value of B is known, the value of sine B is known, because once you know an angle, you can use a calculator to determine the sine of that angle, or you can use a table of values. So that means there's only one unknown in this equation, And if there's one unknown in an equation, you can solve for that unknown. In this case, all you have to do is cross multiply, and you get a times the sine of b is equal to b times the sine of a, which gives a is equal to b sine a over sine b. Like I said earlier, b, uppercase b and a are known. So for instance, let's say b represented a length of 10 units, angle a was say 40 degrees, and angle b was an angle of say 60 degrees. You can easily find a by just simplifying this using a calculator or a table of values. And that's all you need to know. I mean, once you can get an equation where there's only one unknown, you can use the sine rule. Consider this other equation here. This equation b over sine b is equal to c over sine c. Let's say b was known. This angle b was known, so sine of b is also known. And this angle c is unknown, so the sine of c is unknown, but this length c is known. We can find, or you can find, the value of this angle c because there's only one unknown in this equation. All you have to do is cross multiply. So you have b times the sine of angle c equals c times the sine of angle b. We're looking for c, so uppercase c, angle c, so sine c. If you divide both sides by b, you get c times sine b divided by b. And at this point, you can take the inverse sine of both sides to give c. So this is an angle c equals the inverse sine of c times the sine of angle b divided by this length b here. I've just taken the inverse sine of both sides. Taking the inverse sine of the left hand side gives c. Take the inverse sine of this right hand side, this is what you get. The inverse sine of the right hand side term, which is this. So like I said, you can only work out this angle c if this is known, and this is known. So I'm going to give you values. So let's say this length c was 12 units, the angle b was an angle of 50 degrees, and this b here was represented a length of 5 units. You know you can simplify 12 sine 50 divided by 5 on a calculator and find the inverse sine of that value, and you'll be able to find c. So the main idea is, once you can obtain an equation where there's only one unknown, you can use the sine rule to determine that unknown. And the examples you face that will require the sine rule will be cases where you'll be given a triangle and maybe a side or two have unknown lengths, or one or two angles have unknown values, and you need to determine the unknowns. So you just need to try and solve the problem using the sine rule. And anytime you can form an equation from this sine rule where there's only one unknown, maybe just one unknown length or one unknown angle, you know you can cross multiply and simplify to find that unknown. So that's how to use the sine rule. So take this triangle. The lengths of two sides are known. This side has a length of 13 units. This side has a length of 8 units. The other side has an unknown length of a. And then only one angle is given. The other angle is unknown, and this angle here we're not really interested in. The question now is, can the sine rule be used to find this angle b, and can the sine rule be used to find this angle a? So those are the questions we want to answer. To see if the sine rule can be used to find the value of angle b, let's write out the sine rule for this triangle. Well, let's label this angle as angle c. That will give 13 divided by the sine of angle c is equal to 8 divided by the sine of angle b, which is equal to a divided by the sine of 40 degrees. So can the sine rule be used to find the value of angle b? Well, let's see. Here's an equation here. And in this equation, see a different color? In this equation, angle b is an unknown, but angle c is also an unknown. What does that mean? That means there are two unknowns, and I can't solve this equation for b exactly. I'll still have it in terms of an unknown. Remember I said if you can have an equation where the thing you're interested in is the only unknown, you can solve for that unknown. So in this case, just using that equation, we can't find the value of angle B. Let's try this other equation. Here again, the two unknowns A and B. So we can't use the sine rule to find angle B as a first step anyway. What about the length of this side, which is A? Can the sine rule be used? Well, from this equation, no, because there are two unknowns. From this equation, which is this fraction being equal to this fraction, again, there are two unknowns, A and C. So the sine rule can't be used. The next important rule we need to look at is the cosine rule. It also applies to triangles, and the cosine rule is just a set of three equations. So let's start by considering this triangle here, and I'm going to label this triangle as a triangle with three sides with lengths A, B, and C. Notice the lengths here are used as lowercase lengths. The angle opposite to the side of length A is capital A. The angle opposite to the side of length B is capital B. And the angle opposite to the side of length C is capital C. Now for this type of triangle, the cosine rule tells us that A squared, where A is the length of this side, is equal to B squared plus C squared. Notice that B here, B is the length of this side and C is the length of this side. So A squared is equal to B squared plus C squared minus 2BC cos A. Cosine also tells us that B squared is equal to A squared plus C squared minus 2AC cos B. And also tells us that C squared is equal to A squared plus B squared minus 2AB cos C. Now these equations may look complicated, but they're actually very easy. What the cosine rule tells you is that the square of the length of the side, well, with the length of A anyway, so A squared is equal to the sum of the squares of the length of the other two sides, so B squared plus C squared. So you're adding the squares of the length of the other two sides, and then it's minus 2 times B times C times the cosine of the angle opposite this side. And that's the same equation here. Cosine also tells you that, well, if you're looking for what B squared was, B squared is actually equal to A squared plus C squared, where A and C are the length of the other sides, because we picked the side with length B as the side we're focusing on. So cosine tells you that B squared is equal to the sum of the squares of the other two sides. So B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of the angle opposite to the side of length, lowercase b, which is B. And that's the same thing here. And finally, it tells you that C squared is equal to A squared plus B squared. As you know, A and B are the other sides because we're focusing on the side of the length of C, minus 2AB, A times B, times the cosine of the angle opposite this side, which is C. And that's the equation here. So what you need to do is remember these equations, and from what I just wrote now, you can see how you can easily remember the cosine rule equations because there's a pattern to it. So if you can remember them, you can solve questions that are required to use them. When do you use the cosine rule? Well, you use the cosine rule when you're looking for just one term in any of the equations. So let's say you're looking for A, and you knew B, you knew C, you knew B, you knew C, and you knew this angle A. You can easily find A. If you are looking for B, well, if you're looking for B and you knew A, you knew C, you knew, of course, AC, and you knew this B, you could easily find B. If you're looking for C and you knew A, you knew B, of course, A and B, and you knew this C, you can easily find C. You see that what I just said makes sense when we look at examples. But the key thing now here is just remember the equations for the cosine rule. That's the key takeaway from just this section of the video. You need to remember these equations and just please try and remember the pattern I use here. If you pick a side, the length of that side squared is equal to the sum of the squares of the other sides minus 2 times the product of the length of the other sides times the cosine of the angle opposite to the side we were focusing on. It's as simple as that. That's the cosine rule.